We're looking here at how to use the similar triangles to help us solve problems. So our first example here is to actually prove that triangle ABC is similar to triangle XYZ. So we were given three sides of each of the triangles. So I'm thinking side, side, side is our way to go with this. So why don't you give that a shot, as well as doing part B, triangle GHI, why it's similar to the above triangles. And then we're going to go through this little process. So if you want to complete this first page on your own and then compare to what we've got here, it's probably a great idea. You should be able to do that at this point. All right, so our triangles, if we take a short side compared to our short side here, if I do 3 divided by 9, that's 1/3. If I take medium to medium, 4 divided by 12 is 1/3. And if we take large to large, that is also 1/3. So we definitely have similar triangles here. So I have written up my proofs using the side, side, side similarity theorem with this. So I've used the smaller compared to the larger in each of these. So I had a ratio of 1 to 3 compared to 1 to 2, and 1 to 2 for the second pair. You might have chosen to do it the other way around, and then you would just be switching the order of our triangles up here and our side lengths, and you would have a 3 to 1 and a 2 to 1. So how many times longer are the sides of each triangle compared to triangle ABC? So this triangle GHI, its side lengths are twice as big as triangle ABC, so 2 times longer. Sides of triangle XYZ are 3 times longer. These numbers are called the scale factor. So this is the scale factor that you should know. So it's what we're timesing each side by to get to the other things. All right, so determine the perimeter of each triangle here. So perimeters just add up all 3 sides. So the first one is 3 plus 4 plus 5. So that should give us 12 centimeters here. 3 plus 4 is 7, plus 5 is 12. It's 12 centimeters. And you can do your perimeters for GHI and XYZ. And then do the same, but calculate the areas. Now these are right triangles, so you can use the base and the height as your 2 side lengths. So take a moment to do that, and then we'll talk about that. So I've calculated the perimeters here and the areas, and I just want to compare some things. So let's take a look at our comparisons. If I compare 12 to 24, that's really 2 times larger, which is just taking the original perimeter and multiplying by the scale factor. So there's a direct relationship there, and what I want you to notice is if I were to common factor 2 out of every term there, we've got 6 divided by 2 is 3, 8 divided by 2 is 4, 10 divided by 2 is 5. We really have 2 times the original area. Similarly, moving over here, this is really timesing the original 12 by 3 to get 36. And again, I could take a common factor of 3 out of the original numbers that I have up there, and I'm going to have 3 times 3 plus 4 plus 5 again, so 3 times the original perimeter. So perimeter is directly related to the scale factor when we're finding perimeters of similar figures. Now for area, it's base times height divided by 2. The first area was 6. The second area, though, was 24. My scale factor is 2, but really what I have here is 4 times larger. And for the last one, my scale factor was 3, but what I have here is really 9 times larger. So how does this work in? Well, let's look at what we have here. A 6 really is 2 times the 3, the original 3, and the 8 really is 2 times the original 4. So not just the length, but also, or the base, but also the height of the triangle are both being doubled, which really means 2 times 2 is a 4. We're really doing 4 times, whoops, I forgot to divide by 2 here. The original had a divide by 2. That's really 4 times the 3 times 4 divide by 2. All right, so the scale factor is really squared because we've got 2 of those happening. Also, the 54 came from the 9 times 12 divided by 2. 9 is 3 times the original 3 because we're tripling that height. And then we have 3 times the original base, 3 times 4 or vice versa. 3 times this 3 times this 3 is really a 9. That's my scale factor, but I have it twice, so 2 factors of 3 is 9, or 3 squared. And again, divide by 2. That gives us our 3 times 4, divide by 2 there. Okay, so it's the original area, but multiplied by the scale factor square for each of the dimensions that we're working with there. All right, let's go on to the next page here. So to summarize those ideas, the scale factor, which is also sometimes referred to as the scale ratio, is the amount you multiply or divide sides of one triangle by to get the side lengths of a similar triangle. And we always get that by doing our ratio between the two corresponding sides. To get perimeter, it's just a multiplication or division by the scale factor directly, but area has that square of the scale factor relationship there. So you need to multiply or divide by the square of the scale factor. All right, so let's actually use this to help us find some information here. Hugo, so this is my Hugo here, he's standing next to a tall tree on a sunny day. They both cast shadows on the ground. The lengths of each are measured. Hugo's shadow is 4.8 meters long. Now, shadows lie on the ground, so when I label that, it's not the hypotenuse of that right triangle. It is the amount on the ground. So this is 4.8 meters down here on the ground, and the tree's shadow is 75 meters long. Hugo is 1.6 meters tall. I can relate. In fact, I might not quite be 1.6 meters tall. Are the triangles formed in the diagram similar? And explain. Well, there's a couple things to know. Hugo, unless otherwise specified, is standing perpendicular to the ground, as is the tree. Okay, we're going to assume this is flat ground based on the diagram here. So those both make 90-degree angles. So I've got one pair of corresponding angles that are equal. Now here's the other part. I do not have two pairs of sides in both triangles. I have two sides in the first triangle with Hugo, but I only have one side length in the second triangle. So I cannot use sides, but I do have some information about angles. What I know is as long as they're fairly close to one another, because the sun is so far away, the angle at which the sun's rays are hitting the ground will be the same for both objects, both Hugo and the tree, which then means the angle, so the sun, this really represents the sun's ray coming down. It's what's going to cast the shadow because Hugo's blocking the sun's rays coming down, sun ray comes down, hits the ground at the exact same angle as it is for the tree. Okay, sun rays come down, and that's what's casting that shadow. So these two triangles are similar by angle similarity. So let's write that down. And because this is more of a situation and not so much the cold generic triangles in our other questions, we're just going to explain in words here. Both make a 90-degree angle to the ground, so that's one of the pairs of angles, and the sun's rays hit the ground at the same angle. So that's our second angle. So therefore they are similar by angle similarity. So as I said, this works because they're close to each other in proximity. If Hugo was in Vancouver and the tree was here in St. Mary's, that's going to be a problem because we know that the angle the sun's rays are hitting the ground will not be the same. It's a different time zone for that reason. All right, now let's use our similarity to solve for how tall the tree is. I could let x be the height of the tree, so that would be this length here. That side corresponds to Hugo's height. So I know because those triangles are similar to each other, I can use the proportionality to solve for the x. The x, the height of the tree, corresponds to Hugo's height, which is 1.6. The shadow of the tree would be proportional or correspond to the side length, the shadow of Hugo. And now we just need to solve for x. The thing that's keeping x from being by itself is the divide by 1.6, so we can undo that. The opposite of dividing by 1.6 would be multiplying by 1.6. So I'm going to multiply both sides by 1.6, and that will solve for the tree's height. So to put that in my calculator, I'm just doing 75 divided by 4.8. I've got 15.625. I'm going to multiply that by 1.6, and I get 25. So the height of the tree is 25 meters. The tree is 25 meters tall. All right, determine the height of a nearby hydropole if its shadow is 36 meters long. So we could add another picture in here, hydropole. I'm not going to have enough room for this. Its shadow would be 36. So along here is 36. I could let this be P for pole. And again, I can't draw the whole triangle there because I'm running out of room, but we can set up similarity for this as well. The height of the pole would match with Hugo's height. And I'm going to go back to Hugo because that triangle had both sides given to us. The shadow compared to the shadow, and multiply both sides by 1.6 again. So 36 divided by 4.8 gives me that number, which is 7.5 times by 1.6 gives me 12. So therefore the hydropole is 12 meters tall. All right, so moving on here, I've got the next and the last example here. Given our diagram, why are the two triangles are similar, and determine the length of x and y. And this would have been better had I actually given you the values on the diagram, which I will add to mine right now. All right, so I want to show why these triangles are similar to each other. Now I do have two sets of side lengths for each triangle, but I'm going to actually focus on my angles for a moment here because there are some theorems we know from back in the day when we did some angle theorems. I have two straight lines that are crossing each other right here. So that makes this angle in here opposite to this one, and they're equal to each other by the opposite angle theorem. Now I also tried to indicate that this is parallel to this side length. And because they're parallel, I can trace out Z patterns with my with this diagram or on this diagram. If I trace out a Z, we know that in the crux of the Z, those angles have to equal each other. So angle-angle similarity is actually really the easier way to go here. So I know that angle C. Now C is ambiguous because we've got different angles that could be C. We could talk about this one being angle C, we could talk about this being angle C, this being angle C, or this being angle C. Because it's ambiguous, we're going to actually give it a 3-letter name and not just a 1-letter name. But I'm going to start with the other angle. I'm going to say angle B is equal to angle D, because of the Z pattern, or opposite, not opposite angles, alternate angles. So I've got angle B equaling angle D by alternate angles. Now, when I want to talk about the angle here, which I'm shading in green, I'm going to talk about angle BCA. Okay, that will tell me what 3 vertices I'm joining and in what order to create that angle. So if I join B to C and C to A, that's forming the angle I want to talk about. That angle is going to equal DCE because B matches with the D. DCE. Okay, and that is because of opposite angles. And then what we have is that our triangles are similar to each other. Now I'm going to go back and put my other triangle name. B corresponded with D, A ended up corresponding with E. So A corresponds with E. I'm going to say this is triangle E, B corresponds with D, and then C corresponds with the C. All right, so I've got my triangles being similar. Now, I've almost reached my time limit here. See if you can figure out which sides should correspond to each other. Based on how I wrote the triangles, AB should correspond to ED, and so on. BC has to correspond to DC, and then you're going to use that information to solve for the X and Y, or get your scale factor just based on sides that match. So when I set up my ratios, the AB to ED gave us a scale factor of 2.4. That comes from the 12 divided by 5. Multiply both sides by 4, I get X being equal to 9.6. If I want to work backwards, I'm really taking that scale factor to the 17 and the Y are going to match up. If I take my 17 and divide by 2.4, that's going to give me my matching side length Y, which I'm doing right now, 17 divided by 2.4, and that gives me 7.1-ish. It doesn't, it's a repeating decimal, but we'll go with 7.1 meters. All right, so good luck with that. Hopefully that is making sense for you.